Section 3.6, derivatives of inverse function. There are two objectives. In this section, we would like to find the derivative of an inverse function and then differentiate an inverse trigonometric function. Derivative of an inverse function. To understand this, first of all, let's say there is a one-to-one function. Let's say f is a one-to-one function going from domain D to the range R. If it's one-to-one, a reverse of this function is possible, and this reverse process is called inverse of the function f. Normally, we denote this function as f inverse. Let's say this is f of x. The notation for the inverse is f inverse of x. There is a relation between inverse and its function. So the composition of these two functions, which is actually f inverse of x, is always x. Whatever input you take here, the very same output it gives you. And then it happens even you change the order. So even you take f inverse first, it will give you the same thing as an output. So this is the relation we have to understand. So to go further, let's assume that u is f inverse of x. That's the notation I'm using. So because of this relation here, we can say, hey, f of u is equal to x. Now we can find the derivative of inverse by using the chain rule. X. So now if I have to find out the derivative of this left side with respect to x using the chain rule, let's differentiate both sides. Differentiate both sides. If you differentiate both sides with respect to x, then by using the chain rule, I can differentiate this function of u with respect to u times the derivative of u with respect to x on the left side, and on the right side the derivative of x with respect to x is 1. So now as you can see that u is f inverse, and this is derivative of the function of f with respect to u. Okay, so this is actually f prime. This is actually the derivative of f. So you can write it down like this is actually f inverse. No, sorry, this is actually the derivative of f. Okay, so at u, what is u? U is the value of the f inverse at x. Okay, so that times this is derivative of f inverse. That's the derivative of f inverse equal 1. So now to find out the derivative of the inverse function, we just divide both sides by f inverse at u if it's non-zero, and that gives us derivative of f inverse at x equal 1 over f prime at u. U means f inverse of x. That's the value of inverse function at that x. So by using this fact, we can derive this theorem, and this theorem tells us the relation, or the formula, the derivative rule for inverses. If f has an interval I as a domain and f inverse exists and is never 0, if it's 0, then we cannot use this formula because we have to divide by f inverse, sorry, f prime. F prime means derivative. So then f inverse is differentiable, then we can find out the derivative of inverse function, and the value of inverse, the derivative of inverse function is this. Okay, so if you want to see the relation, so I'm just going to draw one thing here. Let's say there is a function f at point A which gives the value b, and we are interested to find the derivative of f inverse function at b. We want to find out the derivative of f inverse with respect to x at b when x is b. This is equal to 1 over the derivative of the function coming from here, f prime of x, when x is a. So look at here, that's the difference when x is a. Okay, so finding the derivative of inverse function is actually the reciprocal of finding the derivative of function itself at this point, which is the inverse point of b. Okay, so let's see one example here. Here is the form, function we have given. We would like to find out the derivative of inverse of this function at point 620. So here is the function f, that's the value of the function, and when x is 5, the value of the function would be 620. So we would like to find out the derivative of this function f inverse at 620. The derivative of f inverse when at 620, x at 620. Remember, this x equal to 620 is coming from here. Then according to the formula, this is equal to 1 over the derivative of the function, f at x equal 5. Remember, don't be confused with this notation x. This x equal 5 is coming from here, this x equal 620 is coming from here. So if you want to find out the derivative of inverse function at 620, you just have to find the reciprocal of 1 over f inverse, which is derivative of f at 5, because the value of the function at 5 is 620, and that's coming from this theorem. So what we need to do, find out the derivative of f, which is f prime at 5, and if you use the power rule, that would be 24x squared minus 30x, and we need to find out the derivative of this function at 5. So the derivative of this function at 5 is 24 times 5 squared minus 30 times 5, which is basically, if you use your calculator, 24 times 5 is 120, right? 120 minus 30 is 90. 90 times 5 is 450. So if you use calculator, that's the value you're going to get. So what's the derivative? What's the final answer? The final answer, the derivative of inverse function when x is 620 is equal to 1 over the derivative of the function at 5, which is 1 over 450. So that's how we find the derivative of inverse function. To find the derivative of inverse function, find the derivative of function itself and find the inverse point of the point where you are looking for the derivative of inverse function. Okay?
Derivative of inverse trigonometric function. That's the next topic we are trying to, achieve here. That's our next goal. And for that, we're going to use the chain rule one more time.
First of all, we have to know there are some standard trigonometric function. The graph of those functions look like this. For example, the graph of tangent of x is this one, sine of x is this one, and cosine of x is this one. By using these three graphs, we can also think about graph of cotangent, cosecant, and secant. Okay, to define trigonometric function, to define inverse of this function, we have to restrict our domain, because inverse is only possible if function is one-to-one. So to define inverse of tangent of function, we are going to restrict our domain from negative pi over 2 to positive pi over 2. That's how there will be one-to-one function. And then we can define inverse trigonometric inverse tangent function. Similarly, for sine x, if we want to find out the inverse, then we have to, we are going to restrict our domain from negative pi over 2 to positive pi over 2, from here to here. In that way, we will have one-to-one function. Similarly, for cosine function, we are going to restrict from 0 to this one, which is pi. So these are the restriction for inverse trigonometric function. For tangent or cotangent, the domain should be from negative pi over 2 to positive pi over 2. For the sine or cosine or cosecant, the domain would be negative pi over 2 to positive pi over 2. For cosine and secant, the domain would be 0 to pi. So think about this. These are the graphs for inverse function for tangent, cotangent, secant, and cosecant. As you can see that the graph for tangent tan inverse is arctan, which is also called arctangent, arccotangent, arcsecant, arccosecant. the domain is the domain is all real number, and then range is from negative pi over 2 to positive pi over 2. So think about this. Here we are restricting from negative pi over 2 to positive pi over 2. This is the domain for tangent of x, where we can define where we can find out the inverse of this function. So that will be now range for the tan inverse. That's why the range is from negative pi over 2 to positive pi over 2 for the inverse function. Inverse means opposite. Here, if we restrict the domain of tangent function from negative pi over 2 to positive pi over 2, these are the domain for this respective function. That will be the range for range for a tangent tan inverse function, cosecant inverse function or secant inverse function. And this is domain and range for cotangent or arc cotangent. So we have to know this information before we try to find out the derivative of function. If you don't know about this function, trigonometric function, then go back and review this material. Okay, so now definition: y equal tan inverse of x is the number in this domain for which tan y equal x. So just take tan y both sides. Tan and tan inverse will be cancelled out, and that's how we get tan y equal x. That's how we define the inverse function. Similarly, cotangent inverse, that is cotangent y equal x, and then do the same thing for rest of the function, and you can do the same thing for cosine and sine as well. So now the main thing we have to do in this section is we need to find out the derivative of function inverse trigonometric function. So we need to derive some formula. The first thing is the derivative of tan inverse of x is 1 over 1 plus x squared. We need to derive that. Okay, we need to find out, we need to prove that. For that, we start with this. Since we know y equal tan inverse of x, it means if y equal tan inverse of x, that means tan y equal x, and that's coming from the definition. If you go back to the definition, this is equivalent to this one. So y equal tan inverse of x is only possible if tan y equal x. Okay, so that's a equivalent definition. So now from here I can go here. My goal is to find out the derivative of y with respect to x. So what do? I just differentiate both sides of this equation. So take derivative both sides with respect to x. Take derivative both sides with respect to x. So this is since this is function of y, we have to use the chain rule here. So the chain rule is find the derivative of tan y and balance it by dy over dx, and derivative of x with respect to x is 1. Okay, so now so what is the derivative of tan y with respect to y? We know the derivative of trigonometric function. If we don't, then we need to review that. Derivative of tangent function is, let me just give you quick of a review. The derivative of sine x is cosine of x. Derivative of cosine of x is negative sine x. Derivative of tangent is tangent of x is secant square x. Okay, so that's what I'm going to use here. Derivative of tangent of y is secant square y, dy over dx equal 1. So what is the dy over dx? From here, if we go to the next step, dy over dx can be written as 1 over secant square y. So what is secant square y? We know tan y is x, and we need our answer in terms of x. So we need to convert this secant square y in terms of x, and that is possible by using this relation. Secant square x minus tan square x is actually 1. So if you have secant, then you can always go from secant square to the tangent square by using this relation. So instead of 1 over secant square y, I can write 1 over tan square y. And I know tan y is x, so I can write down 1 plus x square. That's why the derivative of y with respect to x is 1 over 1 plus x square. But what is y? Y is tan inverse of x. So derivative of tan inverse of x with respect to x is 1 over 1 plus x squared. Okay, so that's the first formula. The derivative of um, tan inverse x is 1 over 1 plus x squared. That's the first formula. We can do the very same thing, for the derivative of cosine inverse x, and then derivative of sine inverse x. We can do exactly the same thing, and we can find out the derivative of these functions. Okay, I'm just going to write down their derivative here, respective derivative here. So derivative of sine inverse of x, the derivative of sine inverse of x is 1 over square root of 1 minus x squared, and then the derivative of cosine inverse of x, cosine inverse of x is, what is that? Let's do that. Let's by doing the same thing, it is also 1 over minus, in this case it's a minus square root of 1 minus x squared. So these are the derivative of this standard, this tangent inverse, cosecant, cosine inverse, and sine inverse function. And we can find out this information by doing the same thing exactly whatever I did here. So instead of x, if you have u, where u is the function of u is the function of x, then we can use the chain rule and we can write it down. The derivative of sine inverse of u with respect to x is 1 over square root of 1 minus u squared times du over dx. That's from the chain rule. And derivative of tan inverse of u is 1 over 1 plus u squared times du over dx. Similarly, secant inverse u is 1 over absolute value of u times square root of u squared minus 1 times du over dx. Okay, so these are some formula you can always derive using the same idea I did here. Let's look at some of the relation between identity, co-function identity between cosine and sine inverse, cotangent and tan inverse, and cosecant inverse and secant inverse. So as you can see that cosine inverse x can also be written as pi over 2 minus sine inverse of x. Cotangent inverse of x is equal to pi over 2 minus tan inverse of x. Cosecant inverse of x equal to pi over 2 minus secant inverse of x. So while finding the derivative of this trigonometric inverse of trigonometric function, this relation might be helpful sometime. So this is the list of derivative. While solving the problem, finding the derivative of inverse trigonometric function, we can use this list, this formula. Let's look at one example. We want to find out the derivative of y with respect to t. So we want to find out the derivative of y with respect to t. According to the formula says the derivative of cosine inverse of u with respect to x is, where u is function of maybe t or function of x. Here it's function of x, but in our example it's a function of t. So that is 1 over square root of 1 minus u square. So that is 1 over, uh, don't forget about this minus, 1 over 1 minus square of u square. So in our case u is square root of 2t. So u square means it's a 2t square times du over dt. So that is 1 over square root of 1 minus 2t square. Find the derivative of this with respect to t. That is square root of 2 only, because the derivative of t is 1. So it's square root of 2. So the answer is negative square root of 2 over square root of 2 1 minus 2t square. Okay, so that's the derivative of inverse trigonometric function. The main idea is you have to understand this formula, you have to know how to find out this formula, and just follow the instruction I give you, the explanation I give you here.